good day and welcome back to Everything Mathematics. And today we're going to continue our series on simultaneous equation. Unlike yesterday where we solved simultaneous equations where the coefficients were the same, today we're going to be looking at simultaneous equations when the coefficients are not the same. So the concept that we learned yesterday, I must admit, everything will be the same today. The only difference is that I'll be showing you what do you do first in the event then if the coefficients are not the same. So let's start with this example. Let's start with an example here. So we have 4x plus 5y is equal to 8. That's all, let's say that's our equation 1. And in equation 2 here, we have 6x minus 2y is equal to 26. 26. Hope I got these numbers right. Good. So in this case, notice that if we choose to eliminate x, they don't have the same coefficient because this x above here has a 4 and this x up below here has a coefficient of 6. And likewise, if we choose the y, the coefficients are not the same. So the trick is this. To make them the same, well, again, you have to multiply the entire matrix by, let's say, a scale factor that will equalize the coefficient. I know that kind of sounds technical and high-tech. But in other words, you have to multiply the matrix, or not the matrix, the equation, by any number, or rather by a specific number that will make them the same. So let's look at I wonder which one should I take? Let's do the y. Let's do the y. No, let's do the x. It doesn't matter really. No. Let's do the x. In this case here, the x is 4 and the x below here is 6. But I want them to be the same. So the easiest way to go through this is multiply the entire equation 1 by 6, and you multiply the entire equation 2 by, guess what? 4. So you multiply by the opposite of each other. But I don't want to say that because, you see, again, I repeat, the aim is to make them the same. And there are many ways you could do that. But multiplication is usually the easiest way. Of course, sometimes you'll have occasions where you don't have to multiply both matrices. Sometimes you just have to multiply one matrix because there's a number you can multiply a certain matrix to make the coefficient of what you're looking for the same. And hopefully I'll have an example like that later on the line. So in this one now, you have to be very careful. A mistake that a lot of students tend to make sometimes when they multiply the matrices, they only multiply what they want the coefficient to be equal to, and they forget the rest of the other terms. So you have to be careful. When you multiply by 6, you multiply the 4x by 6, 5y by 6, and the 8 by 6. Everything. And when we reach below, same thing. You're not just multiplying the 6x by 4, but you're multiplying the 6x, the 2y, and the 26. Everybody will be multiplied by 4. And when you do that, you also are creating a new equation. So let's talk about equation 3 now. Equation 3 now would be 24x plus 30y equal 48. That now is equation 3. And in case you wonder how I got these values again, simple arithmetic. I multiply 6 by 4x, I got 24x. 6 by 5y, I got 30y. And 6 by 8, I got 48. It's a lot, not a lot easier, but it's wise when you know your timetables, so you could see number relationship too. And below, I'm doing the same thing now. 4 multiplied by 6, I'm getting 24x. And that's what we want to see. X the same now because that's the number I chose to eliminate in this case. Minus 4 times 2, that should be 8y. And 26 times 4, 25 times 4 is 100 plus 6, that will be 104. Well, 4 because it's 1 extra from each one. So this should be 104. Let me just make sure. 4, 6 are 24. 24. 4 2s are 8 and 2 is 10. Yeah. So yeah, 104. And this will make equation 4. Good. That's equation 4. And now we have what we want. We have the coefficients being the same. And don't be afraid of them big numbers. Sometimes it does look big, but believe me, they just work out nice. As a matter of fact, let me tell you something. Oh, I didn't make none of these questions by the way. I took all of them from various places, textbooks, internet, whatever. Just grab a question. But one of the things I noticed about simultaneous equation, I might as well share it here. I always notice that oftentimes your value usually end up between 1 and 9. Usually, when you find x and y, you end up with a value ranging between 1 and 9. So in essence, sometimes the numbers look big, but guess what? They work out to be very nice. So let's see this one. I didn't work on none of this, so I don't know the answers, but I'm confident enough to just pick a question and work it out live here. Good. And let's see what the value end up. But yes, as I said, if you look at the yesterday video to all of them, we had one of them where x was 0. But generally, you always get a value between 1 and 9, generally. At least for CSEC, of course. At higher level maths or in any other given scenario, it wouldn't always be that value, naturally. Depends on what you're solving. But yes, for the generic questions and them, I figure that's usually the case. Well, I know you don't have to be, but you just so happen to. Anyway, let's go. So 24 minus 24x, that will give us 0 there. 30y minus 8y, this will actually give us positive 38y. Oh, and sometimes you get a fraction too. 48 minus 104, let me just do this one on the calculator quickly. I am getting here minus 56. Well, I see the answer already. And minus 56 divided by 38, I'm pretty sure that will give us what? Would that give us a nice answer? 56 divided by 38. Nah, shucks. I'm getting a fraction here. Let me make sure. 38, 48 minus 106. Oh, 104. Yeah, that's 56. Ah, well, it is what it is. So here I'm getting 38y is equal to minus 56. And when you divide here by 38, and you divide here by 38, 38 cancels 38. So that leaves you with y is equal to, again, let me just do it last time, 56 divided by 38. I don't like this answer, but it is what it is. 28 over 19. Yeah, that's what it is. 28. Y is equal to 28 over 19. And if we go to write it out as a decimal, that's approximately equal to, so it's still within our range, but say what? That's approximately equal to 1.47 in 2 decimal places, right? But I'm going to work with it as a decimal, as a fraction, I mean. Right, so that's what we get for y, and again, we just follow the rules. We follow the rules. So sub, I don't like the fraction though, but say what? Sub y is equal to 28 over 19 into what equation I'm going to choose. So we have 4 equations at the top. We just go back at the top. We have 4 different equations here. So we have options, if we should put it like that. We have equation 1, equation 2, equation 3, equation 4. Then the one that looks the smallest for me is equation 2. So I'm going to use equation 2. When you're substituting, you're always looking for the one that's easiest to work, right? So equation 2 here was 6y minus 2y equal to 26. 26, not 29. Good. And then we know what is y, so I'm substituting the value 6y is 6x. And we know what is y is that value up there, so that will be 6x minus 2 multiplied by, let's put that in bracket, 28 over 19. Yeah, that's what we got for y. Maybe later I'll see if I did the right thing. 26. Good. If we multiply 2 by that, oh, hold on. That's supposed to be negative, right? Let me see. Oh, yes. This is supposed to be negative. Negative. Yes. My bad. Just I'm gonna look back there. So that's negative 28 over 19. Right, so this negative, when we multiply that by the 2, put it 2 times, well, it will become positive eventually anyway. So 2 multiplied by 28 over 19. All right, so that giving me 56 over 19, so I could just multiply the top technically. So that will be, let me get back to the black. So that will be 6x minus 56, not minus, but plus. 56 over 19 equal to 26. I send that on the other side, so I will have 6x is equal to 26 over 1 minus 56 over 19. And let's just solve that quickly on a calculator. So 26 minus, and then I have in my fraction, 56 over 19. That gives me a big value. And then I divide that by 6, and I end up with something pretty decent. So when I get this whole thing here, so 6x, that's equal to, this is actually 438 over 19. And then when I divide by 6 here, and I also divide here by 6, x will ultimately work out to be 73 over 19, which is approximately equal to, according to my calculator, 3.84. And that's the 2 decimal places. Well, people, I can't say I like these solutions for this one, but it is what it is. I don't usually like working with fraction, but that's my personal preference. Some persons do. And they don't usually end up with a fraction either. Like now I'm tempted to see if I did something wrong, but let's go. The next one hopefully should be a different one. Let's see what we get for the other one. You could always go back and scan through it. Right, so let's do one more. So we have, or maybe two more. X plus 2y is equal to 10. And again, this will be our equation 1. And then we have 3x minus 5y is equal to negative 3. And this is our equation 2. And here, of course, we pick whichever value we want. And in this one, this is a perfect example where we could just multiply one side by 1. Again, I will deal with the x because it's the easier way out. In this case, I want the x's to be equal to 3. This one is already 3, so I want to make this one 3. So the easiest way here is by multiplying this entire equation 1 by 3. Of course, another way could have been dividing equation 2 by 3, so that then this 3 will become 1. But then I'll end up with a fraction here, and I don't want to take that road. So if I multiply equation 1 by 3, and let's hope this one works out even better, we have now 3x plus 6y my equal to 30. 3 times 10 is 30. And that will be equation 3. And then we have equation 2 still, which is 3x minus 5y equal to minus 3. And that's equation 2. So if I subtract here, these 3 x's cancel each other. 6 plus that, that's 11. Oh, well, this one worked out nice already. I could see a nice answer coming out here. This is positive 11y. This is 6y. So this is 11y, and over here, 33 minus minus 3, 30 minus minus 3, that will be 33. Yeah, this one better. Well, it don't better, but it worked out nicer. 11y is equal to 33. That divided by 11. You do it on the same side on both sides. So y is equal to 3. Much neater answer, at least for my liking. But I know for a fact when you're doing maths, it will always work out like that. So now we're subbing y is equal to 3 into equation 1. Let's choose equation, let me see. Let's take equation 1. Equation 1 is the easier one. So we have x plus 2y is equal to 10. Good. And here now, let's see, we know that y is 3. So we have x plus 2 equal to 10. and y we know is 3. So we're solving that now. So that's x plus 6 is equal to 10. As a result, x will be equal to 4. Yeah, that looks legit. So y is equal to 3. That's right here. Y is equal to 3. X equal to 4. I prefer it when they work out like that, but I know it doesn't always have to work out like that. I wouldn't be naive to not acknowledge that. Let's try one more, a last one. I want to get rid of y's. So we've been handing x right through. Let's do a y now. So we have 5x plus 2y is equal to 31. That's equation 1. And then instead 3x minus 5y is equal to, I think I write the wrong thing. I copied the wrong thing. So you have 5x plus 2y is equal to 31. Yes, and below I have x minus 3y is equal to 13. Let's see if this one work out nice. But again, this time I say I want to deal with y, right? So I want to make the coefficient of y the same. As is here, there is a 2 here, and there is a 3. I want them to be the same. So again, I multiply by opposite factors. So I multiply the top by 3, and I multiply the bottom by 2. That will help to make both of them the same. So at the top now, I will end up with 15x plus 6y equal to 3 times this is supposed to be what? 93. So this is a new equation, 3. And at the bottom now, I should end up with 2x minus 6y equal to 13 2s are 26. 26. And that's equation 4. And since the signs are opposite, I will subtract. That will help me to eliminate. No. Add. Positive 6 plus a minus 6 will add up to be 0. So 15x plus 2, that is 17x. 6 plus minus 6, that will give me 0. So I eliminate the y. And 96 plus 26, I cannot see this one. 96 plus 26, that is 122. According to my calculator, I make a mistake. 93, not 96. 93 plus 26, right, that's 119. I wonder if 119 is a factor of 17. Well, what do you know? It actually is. So I didn't know that. So 17x is equal to 119, and I just plug it on my calculator there. When I divide here by 17, and I divide here by 17, of course, this 17 cancels this 17 and leaves us with x, and this actually works out to be 7. 119 divided by 17 is actually 7. So that means 7 times 17 is 119. One of the disadvantages of learning your timetables all the way up to 12 and not 20 sometimes. I tend to forget the higher ones too. Right, so we know that x is 7, and that looks like a plausible answer again for me. So x equals 7 into, we're choosing another equation, into equation, which one are we going to choose? Let me go back and see. So we have 1, 2, 3. Oh, equation 2 seems to be the easier one again. This one here. So I'm going to choose that equation there. So x minus 3y. So that's equation 2, which is x minus 3y is equal to 13. Good. And we know that x is 7. So where we see x, we just put 7. We just substitute. So 7 minus 3y is equal to 13. I send the 7 on the other side. So that's minus 3y is equal to 13 minus 7. That's what it will become. And that will be minus 3y is equal to, that will be what? 6, positive 6. And at the end of the day, divided by negative 3, divided by negative 3, Negative 3 cancels negative 3. So y will be equal to negative 2. Yeah, and that will be our answer here for y, and our x when y is equal to negative 2 is this one here, negative 3. I mean, x is 7. So when x is 7, y is negative 2. Oh, well, I trust we got the concept. So again, in essence, we just have to make sure that the coefficients are the same by multiplying by a factor that will equalize them. Sometimes we just do a one-way multiplication. Sometimes we do a two-way multiplication. Division is also plausible. I would advise you to divide in the event that, of course, you would not end up with a too awkward number to work with. You know, so like if you could divide and you ended up with whole numbers and at the same time through that process you're making the coefficient the same, yes, you could divide. It is a possibility. But I would say those are rare too. They are scarce. Scarcely you may have to perform division over multiplication of one factor or both factors. So yes, that will bring us to the end of today's video. I trust that was clear. If it wasn't, of course, feel free to leave a question in the comment section below. Or of course, you could email me as I would have given you my email in one of the first things that I would have done way back when, if you remember. All right, so until then, of course, you take care. And tomorrow, God willing, we're going to look at this guy's linear equation. So how can we solve linear equations sometimes when they come as a disguise? So first of all, of course, you have to be able to identify it, and then we need to know how to go about solving it. So until then, you take care.